Airships are lighter than air aircraft, which means they fly using buoyancy instead of dynamic lift like planes and helicopters. In some respects, airships move through the air similar to how boats move atop of water and how submarines move underneath. Ships, including steel-hulled ships, float on water as the air in their hold is less dense than the water around them. Likewise, airships float in air as the lifting gases in their holds are less dense than the air around them, making the whole vessel less dense than the air. Air has a density of 1.29 kilograms per cubic meter, while the most common lifting gases of hydrogen and helium have densities of 0.09 kilograms per cubic meter and 0.12 kilograms per cubic meter respectively. That means that a cubic meter of helium can lift roughly a kilogram, while a cubic meter of hydrogen can lift roughly 8% more, or around 1.1 kilograms. As one can see, the difference in density between even the best lifting gases in air is not that much, unlike the difference in density between water and air. Water has a density of 1,000 kilograms per cubic meter versus air's 1.29 kilograms per cubic meter. That is why airships are so huge yet can carry so little, versus ships, which even a small boat can carry much more than even some of the largest airships. Airships control their altitude through several means. They can drop ballast like sand or water to decrease their relative density and increase their altitude. They can release lifting gas to increase their relative density and decrease their altitude. They can heat up the gas within them to decrease its relative density and increase their altitude. They can cool down the gas within them to increase its relative density and lose altitude. They can fill balloonets or small balloons within their hull with air to increase the relative density of the airship and lose altitude. Or they can use dynamic lift, similarly to planes, to increase altitude. Though using dynamic lift, they cannot hold that altitude without forward momentum. Outside of altitude control, airships handle similarly to airplanes, with propulsion handled by engines and general control handled by flaps, ailerons, elevators, and rudders. Airships require engines for propulsion, as other means have been found to be impractical for general propulsion. One cannot sell an airship like one sells a ship on the sea, for the whole airship is one giant sail blown wherever the wind wants to blow it. Sailing ships on the sea can sail at angles to or even against the wind because of the difference in density of the water that is sailing through and the wind that is blowing them along. While airships are more like submarines, moving through a medium of consistent density. If an airship without propulsion tried to use its rudders to go at an angle to the wind, it would merely rotate and be blown along in the same direction, as there is no difference in density for it to push against. Similarly, one cannot merely row an airship through the air, as once again there is no difference in density of the mediums one is moving through to push against, though if one gets creative with how they use wing-like oars, they could gain some propulsion, but not enough with manpower to fight against the strength of the wind. Once again, airships are huge and light. They are like a sail blown off and lost to the wind. Though one can use variable buoyancy propulsion to move an airship against the wind without an engine, though this requires repeated dropping of ballast and releasing of gas, so it cannot be done for a prolonged period of time, as eventually one will run out of both ballast and gas. There are three main types of airships: non-rigid airships or blimps, rigid airships, those normally known as airships, or sometimes called zeppelins, though zeppelin refers only to airships made by the Zeppelin Corporation, and semi-rigid airships. Non-rigid airships or blimps are in all practical senses a balloon with a basket known as a gondola hung beneath them. They are the least expensive and simplest to build and test. They also take up less space when landed as the balloon can be emptied to shrink their size, though blimps are harder to control and harder to make large as their hull is easily deformed, as it is merely a giant balloon. This is a problem because if you mount engines or control surfaces to the hull, any change in pressure will adjust how those control surfaces are set up and change the aerodynamics of the blimp. The engines on blimps are normally attached to the gondola, though control surfaces are still normally attached to the hull, though any changes in pressure once again will make those control surfaces less effective. In many ways, rigid airships are the opposite. They consist of multiple gas cells or bags within a rigid hull that is usually made up of an aluminum frame and canvas skin, or sometimes a wooden frame and canvas skin. Because of that extensive frame, they are the most expensive and most complicated to design, build, and test. They also take up the most space due to their rigid hulls. Though it is much easier to make a rigid airship large and easily controllable than a blimp is, because you can mount the engines and control surfaces to the hull without worrying about deformation. Also, the gas cells within a rigid airship can be filled to partial pressure to allow it to rise to and drop down from higher altitudes without gas leaks than a blimp can. Rigid airships are much more durable than one might expect, even those filled with flammable hydrogen, as because they have multiple gas cells, leaks may spring in one or two without them losing control and falling all the way down. They merely need to lose ballast. In contrast to blimps, which if a leak springs, they are going down, though normally in a slow, controlled manner. Semi-rigid airships are the middle ground between non-rigid and rigid airships. They have a partial frame on which the gondola, gas cells, engines, and control surfaces are attached. This makes them easier to control and harder to deform than blimps, though not as controllable and not as hard to deform as rigid airships. Though they are more weight efficient than rigid airships, and they can also be collapsed like blimps, unlike rigid airships. Airships achieved man-powered flight long before airplanes. After the first manned balloons were launched in 1783 in France, people sought a way to control them, though wings, propellers, and oars powered by human muscles were not capable of fighting against the wind. Then in 1852, Henry Giffard designed a steam-powered airship which he was able to control and fly at angles to the wind, though it could not fly straight into a decently strong breeze. In 1863, Solomon Andrews designed a variable buoyancy airship which could go against the wind, but it could only do it for a short amount of time because it could only carry so much lifting gas and ballast. Finally, in 1884, Charles Renard and Arthur Constantine Curbs designed an airship powered by an electric motor that could fight against the wind, though airships still were not practical for common use. It wasn't until Count Ferdinand von Zeppelin established the Zeppelin Corporation in Germany in 1900 that airships started to be practical for both air travel and aerial warfare. After that, airships began to be designed and used in Germany, France, Britain, the United States, and many other nations, though they were still large and expensive to build, so they were limited in number. During the First World War, Germany used airships extensively as scouts and bombers to attack both France and Britain. The British found airships difficult to deal with, as at first airships flew higher than planes could reach, then once they made planes that could catch them in altitude, regular machine guns had little effect on them, as you could fill them with hundreds of holes and they'd just fly away. Even incendiary bullets at first had limited effectiveness, as often they didn't have enough thermal energy to ignite the hydrogen, though they were much more effective and in time they did reliably ignite the airships. After World War I, Germany was forced to surrender many of their airships, which allowed the British and the US to examine them and improve their own airship designs. The 1920s and early 1930s were the heyday of airships, as they were used for hundreds of flights, including many across the Atlantic and some around the world. Though the limitations that would lead to the downfall of airships were already evident. As previously stated, airships were expensive and time-consuming to design, build, and test. Also, hydrogen is flammable, leading to extra danger in any failure in their testing or use. While helium, the best alternative to hydrogen, was expensive and much harder to obtain as the US held a near monopoly on helium production at the time. British airship development ended after the crash of R-101, a civilian airship that crashed in 1930, killing 48 of its 54 passengers, making it the third deadliest airship accident. The United States continued with airship development into the mid-1930s, with the USS Akron and Macon, helium-filled airships which were the biggest at the time, and also were flying aircraft carriers. They were meant to be naval scouts that could scout in front of the fleet, with both their planes and themselves. They were proven to be effective in trials, though both met sad ends. During a powerful thunderstorm off the New Jersey coast, the Akron crashed into the Atlantic in 1933, killing 73 of its 76 crew. They died mostly of drowning in the frigid conditions of the Atlantic Ocean. It is the deadliest airship accident in history. The Macon continued in use for 2 years after that, though in 1935 it met a similar fate when it crashed into the Pacific during a storm, though only 2 of its crew died as they had rafts and the conditions were warm. Both the Macon and Akron had the same flaw in their rudders, which caused strong wind shear to rip them off and tear open multiple of their gas cells. The crashes of the Akron and Macon ended the development of rigid airships in the United States, though non-rigid airships continued in use into the 1950s. During the same time, Germany and the Zeppelin Corporation once again returned to dominate the airship industry. In 1928, the Zeppelin Corporation built the Graf Zeppelin, which is arguably the most successful airship ever built. Between 1928 and 1937, it completed 590 flights, including one around the world. It was able to do this because of its unique design. It was still a hydrogen-filled airship, but it had a new fuel, known as Blaugas, which is roughly as dense as air. This meant that when it burned fuel, it did not need to release hydrogen to maintain its altitude, which meant it didn't need to carry as much lifting gas or as much ballast to fly for long distances. This allowed it to fly longer and further than other airships. Though the Graf Zeppelin is often overshadowed by its larger and much less successful cousin, the Hindenburg, which only completed 63 flights before its disaster. In 1937, at the end of a transatlantic flight, the Hindenburg burst into flames while landing in New York State. The causes of the fire are uncertain, though it may have been static electricity built up on the ground and in the tower from recent lightning storms, it may have been arson, or it may have been leaking gas getting ignited by one of the engines. The Inferno destroyed the airship in less than a minute, yet only killed 35 of the 97 passengers and crew, making it the 5th deadliest accident. Many of the passengers were able to escape because the fire started at the back of the airship, they were close to the ground, and hydrogen is lighter than air, so the flames mostly rose into the air above them. Yet because the Hindenburg disaster was caught on film, it is remembered beyond any other airship accident and is often attributed as ending airships, even though airships were already on their way out before then. Then in 1940, the sister ship of the Hindenburg, the Graf Zeppelin II, was scrapped so that its aluminum could be used in the German war effort for World War II. Though non-rigid airships continued to be used during World War II for spotting and naval scouting, some U.S. blimps managed to catch and even sink U-boats. Blimps were said to be rather effective at protecting shipping from U-boats, though their use was limited. After the war, blimps fell out of use for most things besides scientific testing and advertisement. Airships did not lose out to airplanes only because of their accidents, though it didn't help. As stated previously, airships have to be big, which makes them expensive and time-consuming to design, build, and test. One can build and test multiple small planes for a fraction of the cost it takes to build and test a single airship. Airships also require much more material to build than airplanes do. On top of that, airships are slower than airplanes, with the fastest of the historical airships only achieving slightly more than 70 miles per hour. This meant that at that time a flight in an airship took 2 to 3 times longer than a flight in an airplane. Now with faster airplanes, it is much, much worse. So even though airships of the time could carry more cargo than airplanes of the time, airplanes of the time could make the trip much faster and thus carry more cargo in the same amount of time. It is also easier to make an airplane carry more than to make an airship carry more, as airplanes fly through dynamic lift where airships fly through buoyancy. With airplanes, a small improvement in engines or wing design can make a big difference, while with airships, you mostly just need to make them bigger. Though this does not mean that airships are without merit, or that they are entirely abandoned, for there are still modern airships being designed hoping to revive them, for airships have unique advantages, like their ability to hover without expending fuel, and their ability to travel long distances while spending minimal fuel, especially if they travel in wind currents. Like there are new airships being designed by the Zeppelin Corporation. To find out more, you can go to airships.net, where you can learn about both historical and modern airships.